In this video, we'll go through and break down several important EDA steps. Namely, the first, getting domain knowledge step, second, checking if data is intuitive, and finally, understanding how the data was generated. So let's start with the first step, getting the domain knowledge. If we take a look at the competitions hosted on Kaggle, we will notice they're rather diverse. Sometimes we need to detect threats on three-dimensional body scans, or predict real estate price, or classify satellite images. A competition can be on a very specific topic which we know almost nothing about. That is, we don't have a domain knowledge. Usually we don't need to go too deep inside the field, but it's preferable to understand what our aim is, what data we have, and how people usually tackle this kind of problems to build a baseline. So our first step should probably be searching for the topic, Googling, reading Wikipedia, and making sure we understand the data. For example, let's say we start a new competition in which we need to predict advertisers' cost. Our first step is to realize that the competition is about web advertisement. By looking and searching for the column names, using any search engine, we understand that the data was exported from Google AdWords system. And after reading several articles about Google AdWords, we get the meaning of the columns. We now know that impressions column contained the number of times a particular ad appeared before users, and clicks column is how many times the ad was clicked by the users. And of course, the number of clicks should be less or equal than the number of impressions. In this video, we will not go much further into the details about this dataset, but you can open the supplementary reading material for a more detailed exploration. After we've learned some domain knowledge, it is necessary to check if the values in the dataset are intuitive and agree with our domain knowledge. For example, if there is a column with age data, we should expect the values rarely to be larger than 100, and for sure, no one ever lived more than 200 years, so the values should be smaller than 200. But for some reason we find this super huge value 336. Most probably is just in a typo, but it should be 36 or 33, and the best we can do is manually correct it. But the other possibility is that it's not a human age, but some alien's age, for which it's totally normal to live more than 300 years. To check that, we should probably read the data description one more time, ask on forums, maybe the data is totally correct and we just misinterpret it. Now, take a look at our Google AdWords dataset. We're understood that the values in the clicks variable should be less or equal than the values in impressions column. And in our case, in the first row, we see 0 impressions and 3 click events. That sounds like a bug, right? In fact, it probably is, but differently to the example with person's age, it could be rather a regular error made by either a data exporting script or another kind of algorithm. That is, the errors were made not at random, but there is some kind of logic why there is an error in that particular place. It means that these mistakes can be used to get a better score. For example, in our case, we could create a new feature is incorrect and mark all the rows that have errors. Probably our models will find this feature helpful. It is also very important to understand how the data was generated. What was the algorithm for sampling objects from the database? Maybe the host sampled the objects at random, or they oversampled a particular class. That is, they generated more examples of that class, for example, to make dataset more class balanced. In fact, only if you know how the data was generated, you can set up a proper validation scheme for models. Coming up with the correct validation pipeline is crucial, and we will discuss it later in this course. So, what can we possibly find out about generation process? For example, we could find out that train and test set were generated with different algorithms. And if the test set is different to the train set, we cannot use part of the train set as a validation set, because this part will not be representative of test set, and so we cannot evaluate our models using it. So once again, to set up a correct validation, we need to know underlying data generation process. In the ad competition we've discussed before, there were all the symptoms of different train test sampling. Improving the model on validation set didn't result into improved public leaderboard score, and more, the leaderboard score was unexpectedly higher than the validation score. I was also visualizing various things while trying to understand what's happening, and every time the plots for the train set were much different to the test set plots. This also could not happen if the train and test set were similar. And finally, it was suspicious that although the train period was more than 10 times larger than the test period, the train set had much fewer rows. It was not straightforward, but this triangle on the left figure was the clue for me, and the puzzle was solved. I've adjusted the train set to match test set, the validation score became reliable, and the modeling could be commenced. You can find the entire task description and investigation in the written materials. So, in this video we've discussed several important exploratory steps. First, we need to get domain knowledge about the task, as it helps to better understand the problem and the data. Next, we need to check if the data is intuitive and agrees with our domain knowledge. And finally, it is necessary to understand how the data was generated by organizers, because otherwise we cannot establish a proper validation for our models.